Put two perfect clocks together, set them to the exact same time, then move one clock upstairs. Wait long enough and they will disagree. Neither clock is broken. Time is. And that is only the first crack. Physics has found places where time slows, where two people cannot agree on what is happening now, where causes lose their normal order, and where the deepest equations seem to forget time completely. We are going through 7 ways time can break. Each one is stranger than the last. But hold on to one question. If time is not a basic part of reality, what exactly has been carrying you from yesterday into today? This is Bobby. Bobby owns a very accurate clock. One morning, he puts it in a fast spaceship and sends it around Earth. He keeps an identical clock at home. When the traveling clock returns, it is slightly behind. That is, break number 1, speed changes how much time you collect. The faster something moves compared with you, the less time passes for it compared with you. This is called time dilation. It is not an illusion, and it is not just how the clock looks. The traveler really can return having aged less. At normal speeds, the difference is tiny. Near the speed of light, it becomes huge. Imagine Bobby flies through space for what feels like 5 years. When he returns, 50 years may have passed on Earth. He did not jump through a glowing portal, he simply took a shorter path through time. Now the uncomfortable part. There is no single amount of time between two meetings that every traveler must share. Your path decides how much of your life you receive. Break number 2 is gravity. Bobby places one atomic clock on a table and another on the floor. The clock closer to Earth ticks more slowly because it sits deeper in Earth's gravity. Scientists have measured this effect with clocks separated by only about a millimeter. Your head is aging a tiny bit faster than your feet. Do not celebrate. The difference is far too small to save you from your birthday. But near something extremely heavy, like a black hole, the split becomes enormous. 1 hour for Bobby near intense gravity could match years for someone far away. Speed and gravity do not merely affect clocks. Clocks reveal what time itself is doing. So now Bobby has 2 ways to reach the future: move extremely fast or spend time near extreme gravity. Both tickets are one way. Break number 3 is worse because it destroys a word you use every day, now. Picture Bobby standing halfway between 2 distant lightning strikes. He sees both flashes at the same moment. Someone racing past him may calculate that the left flash happened first. Someone racing the other way may calculate that the right flash happened first. All 3 can be correct. For events far apart, the universe does not provide one master answer for what is happening right now. Simultaneous depends on how you are moving. This does not scramble cause and effect. If one event can physically cause another, observers still agree about their order, but there may be no universal present sweeping across the whole cosmos. Your now may not reach the stars in one clean slice. And if there is no shared cosmic present, the idea that the universe is updating one frame at a time may be something your brain invented. Break number 4 waits at a black hole. Bobby watches a friend fall toward the event horizon, the point beyond which light cannot escape. From Bobby's distant view, the friend appears to slow down. Each new signal takes longer to arrive and becomes redder and dimmer. Eventually, the friend fades from sight. But for the falling friend, their own clock keeps ticking normally. If the black hole is large enough, they can cross the horizon without seeing a giant wall or a frozen clock. 1 event. 2 descriptions. From far away, Bobby never receives a final signal announcing the crossing. For the traveler, the crossing happens after a limited amount of personal time. Time has not simply stopped. The paths that information can take have been torn apart. This matters because every clock is also a witness. Near the horizon, the witnesses cannot reunite and compare notes. Break number 5 is hiding inside your kitchen. Drop a glass and it shatters. You never see the pieces leap together and land in your hand. Smoke spreads through a room. It never gathers itself back into the candle. Yet many basic equations work almost as well forward as backward. They do not contain a bright arrow labeled future. So why can Bobby remember yesterday but not tomorrow? The best clue is entropy, the number of ways tiny pieces can be arranged. There are very few arrangements that look like a perfect glass and countless arrangements that look like broken pieces. Things move from special, ordered arrangements toward more common, mixed-up ones. That statistical drift gives us an arrow of time. In a tiny system, brief, backward-looking fluctuations can happen. Across an entire room, they are so unlikely that waiting for one would make forever sound short. This means the direction of time may not be a command written into every law. It may be the direction in which disorder is overwhelmingly easier. If the early universe had not begun in an unusually ordered state, the arrow we live by might never have appeared. Break number 6 bends the arrow into a circle. Einstein's equations contain strange mathematical worlds where a path through spacetime can return to its own past. Physicists call these closed, time-like curves. Rotating universes, certain spinning black hole solutions, and imagined wormholes can produce versions of them on paper. So Bobby enters a tunnel on Friday and exits on Thursday. Now he can stop himself from entering. But if he stops himself, who came out on Thursday? This is the grandfather paradox wearing Bobby's orange scarf. Some ideas force events to remain self-consistent. Bobby can visit the past, but he can never change the fact that he visited. Other ideas split outcomes into different histories. And many physicists suspect nature blocks the machine before any paradox begins. The tunnel may collapse. Quantum effects may explode. The required negative energy may be impossible to control. The equations leave a door-shaped outline. That does not mean the universe built the door. Before the final break, here is a real experiment that sounds like science fiction. In a quantum switch, two operations can be arranged so there is no single definite answer to which happened first. Researchers have demonstrated this with particles of light. It does not mean a photon murders its grandfather. It means the order A then B and B then A can exist in a quantum combination before measurement. At tiny scales, even before and after may not always behave like fixed boxes. Now break number 7. When physicists try to combine quantum theory with Einstein's theory of gravity, some of their deepest equations do not include ordinary time in the way we expect. This is called the problem of time. The universe, viewed all at once, can look frozen. No master clock outside reality tells it when to move to the next moment. One possible answer is that time is not fundamental. Maybe time appears only when one part of the universe changes compared with another. A clock does not measure an invisible river. It counts change, and your brain turns those changes into a journey. Think of temperature. One atom does not really have a normal room temperature. Temperature appears when huge numbers of particles interact. Time could be similar, real and useful at our scale, but missing from the deepest list of ingredients. That idea is not proven. We do not yet have one complete theory joining gravity and quantum physics. But now, return to Bobby's first question. If time is not basic, what carried you from yesterday into today? Maybe nothing carried you. Maybe yesterday's universe contains memories and records that connect it to this one. Maybe movement through time is the story formed by those connections. Bobby checks his clock. It tells him that 10 minutes have passed. But the clock moved at one speed, inside one gravitational field, along one path through space-time. It measured Bobby's time, not the universe's. There may be no clock for everything, no single now, no guaranteed arrow, and, at the bottom of reality, perhaps no time at all. So here is the choice. If you could travel into the future by giving up 10 years with everyone you love, would you go? Choose carefully. The future may be a place, but time is the price of the ticket.